Hello everyone, welcome back to my YouTube channel. Today we are going to discuss about partial orders. What is partial orders? Partial orders are an important mathematical concepts that describe relationship between element in a set. They allow us to compare and organize elements in a structured way with a focus on understanding the inherent hierarchy and dependencies within the set. Definition of partial orders. Reflexive, transitive, and antisymmetric are the types of partial orders. Reflexive, each element is related to itself. Transitive, if A is related to B, then B is related to C, then A is also related to C. Antisymmetric, A is related to B, B is related to A, and AB must be the same element. Here, A and B intersect. The intersect of A and B, the set of elements in both A and A union B, the union of A and B, the set of the elements in both A and B in the second image. In the third picture, B complement. The complement of B, the set of elements not in B, which is the absence of the elements in the B. Hasse diagrams, visual representation. Hash diagrams are a graphical way to depict partial orders using nodes and lines to show the relationship between elements. By using these diagrams, we show the relationship between the nodes and lines to depict the partial order in a graphical order. Simplifies comparison. It makes easy to understand and compare the elements in a partial order by highlighting the hierarchy and connections with the help of hash diagrams. Transitive reduction. It only shows the direct relationship, removing any transitive edges of a cleaner visual by using transitive reductions. Properties of partial orders. Maximal elements, minimal elements, chained and anti-chains lattices. These are the properties of partial orders. Maximal elements. Partial orders can have one or more maximal elements, which are the top elements in the hierarchy. Minimal elements. Partial orders can have one or more minimal elements, which are the bottom elements in the hierarchy. Basically, in the hierarchy, the top elements are considered as the maximal elements, and the bottom elements in the hierarchy are considered the minimal elements. Chains and anti-chains. Partial orders can contain chains, totally ordered subset, or anti-chains, subset with no comparable elements. In partial orders which contain chains, they are totally ordered subsets. The opposite of it, which does not subsets which are no comparable elements are called anti-chains, lattices. Partial orders with additional properties like the existence of least upper bound and the greatest lower bound are called lattices. Example of partial order relation, antisymmetry. Suppose f is lesser than or equal to g and g is lesser than or equals to f, then f is o to the power g of x and o g of x, and g of x is o f of x, then f of x is o g of x, therefore f is equals to 0, therefore f is equals to 0. Let's consider here, they consider f and g are the two elements where f can be lesser than or equal to g, and similarly g is lesser than or equal to f. When f is o of g of x and g is o of x, then f of x is equals to o of x, therefore both f and g are equal. They concluded here. Representing partial orders with Hasse diagrams. In the left of my screen, which is right of your screen, we have the Hasse diagrams. Here GGG and it is the top of the hierarchy, and GD, UGG, GGG, GGA, AGG, GAG. These are the maximal hierarchy, and going on to the minimal of hierarchy, which is CCC, CUC, UCC, CCC, CCA, ACC, and GSC in the hazard diagram, where we can represent the partial orders in a hierarchy. Notes: each element in the partial order is responded by a node in the hazard diagram. See, GGG is a node, GUC is a node, UGG is a node, GGU is a node. Each element in the partial order is represented by nodes such as which is GG is a node. Edges. Directed edges between a node shows the direct relationship between the elements. Here, the path or the line between GGG and GUG is called the edges, which shows us the direction between the two nodes, which are GGG node and GUC node, which also shows the direct relationship between the elements across the hazard diagram in the hierarchy. Transitive reduction. The diagram shows the minimal required edges, removing any transitive relationship. It shows the minimum edges or the least edges with removing any transitive relationships. Here we can have a diagram with less edges and also without removing any transitive relationships. Comparing elements in partial order greater than for element A and B, A is greater than B and A is above B in the hazard diagram. See, if we consider GGG as A, GUG as B, these two are elements in the hierarchy where A is GGG, which is above the GUC, which is B, lesser than element. Let's consider A and B. A is less than B as A is below the B. Suppose we consider GUG as 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 A and GGG as B, where GUG A is below the B, GCC which is lesser than. Incomparable. If two elements not be compared using a partial order relationship, they are considered as incomparable. See, I consider GGG and AAA, which two are not present in the other diagram. They cannot be compared. So it is an incomparable element. Example: minimal and least elements. Minimal and least elements are similar to maximal and the greatest elements respectively. The element small a belongs to A in a minimal element if for all B belongs to A. Either A belongs to A is lesser than or equals to B, or B are not comparable. An element A belongs to A is a least element if all B belongs to A and A is equals to B. Application of partial orders. Computer science, mathematics, and decision making are the in these platforms we can apply the partial orders. Let's see how. In computer science, partial orders are used to model dependencies, inheritance, and other hierarchical relationships in data structures and algorithms. Mathematics. Partial order are partial orders are fundamentals to areas like abstract algebra, topology, and in other theory, providing a framework for understanding complex structures. Decision making. It helps with the decision making by organizing options, identifying constraints, and clarifying the relationship between alternatives. Conclusion and key takeaways. Partial orders explained. It is a fundamental mathematical concept of organizing and comparing elements in such a way. Hasse diagram. Hasse diagram provide a visual representation of partial orders, highlighting the relationship and hierarchy between the elements. Practical application, which we saw in the black slide, where CSC mathematics and decision making. In CSC, it used model dependency, inheritance, and hierarchical relationships and data structures and algorithms. Mathematics, which is a complex structures, topology, abstract algebra, and other theory, providing a framework for understanding complex decision making in organizing options, identifying constraints, and clarifying the relationships. These